In today's episode, Cisco CX engineers and architects tell us about cruise ship networks.
Everything runs over the same network, so it's like door locks, security cameras, navigation stuff, and customers browsing internet, pulling content.
And what makes them special in terms of criticality and security.
Segmented properly, secured properly through firewalls, through VRFs, through segmentation. That's very important. And the difference to like normal computer networks is in that the internet connection is satellite. So it can come and go. Any content that customers need and users need on the ship has to be locally stored on the ship.
They talk about ship scale.
6,500 passengers, 18 decks, 2,800 cabins.
And the pressure that comes with it.
Stressfulness of the short timelines. There's no delays. Like, you can't delay this because the ship has to sail. They're going to lose millions if it doesn't sail, and reputation. If you're like, oh, the ship was late for sailing.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Hello and welcome to episode 36 of the Cisco Tech Stories podcast. I'm Tristan, and as always, I'm joined by Nico. Hi, Nico.
Hello. Imagine a floating city. Thousands of guests, casino, theater, critical operation systems, and a complex digital infrastructure that spans every deck. Now, imagine having to perform a full-scale network upgrade on that city in a very limited time frame, while the boat is also undergoing maintenance at the same time, with absolutely zero room for error and no tolerance for downtime, as around 1,000 workers are relying on the same network to do that maintenance.
It sounds like mission impossible, but for our three guests today, it was almost just another day at the office, or more like another day at the dry dock to be exact. In this episode, we are diving into the high-stake world of maritime network engineering. We'll explore how this expert leveraged state-of-the-art technologies to execute massive upgrades under extreme pressure.
We'll discuss the risks they faced, the unexpected challenges that threatened to derail the projects, and the rapid, innovative problem-solving they used to keep the systems and the ship running smoothly. If you've ever wondered what it takes to manage a mission-critical deployment where downtime or delay are simply not options, this is a story for you.
Let's get started.
Let's welcome our three guests. Hello, Goran.
Hey guys, my name is Goran Ristik. I'm a CX delivery architect with Cisco. I've been with Cisco for 15 years, and I had the pleasure to work recently on this project, which was very interesting and one-off. It was upgrading the network on a cruise ship. So it was very exciting for us. We had to travel, be on site, and we had to do many things that we don't usually do in our normal work day in Cisco.
Okay, and we have Joe as well.
Hi, my name's Joe Antanis. I'm a solution architect at Cisco over 20 years, and I was involved in this project on site in the dry dock for these cruise ships. Did a couple of them, upgrading the network to a new solution.
And Yanni?
Yanni Fellis, I'm an architect in product management at CX. I was also part of a cruise ship network upgrade with Joe and Venkat as well, who's not on this call. We were all on site on a dry dock, which I'm sure we'll talk about all the interesting stuff, especially Joe, since he was on the actual ship, or ships per se, because there are two ships there. We're only working on one. And like Goran said, it was very interesting because it's not something we see in day-to-day data centers or campus designs. So, not a lot of people don't think that a ship has an actual data center, and campus side or data center side, and racks and everything else that you would think that would be in a regular data center, I guess.
How did the project come about? Were you approached by the customer saying, okay, we need to upgrade our cruise ship, or how did it start?
For the cruise ship that our team did, I was actually working in the lab on something which was very coincidental that the customer was looking for, and that is doing multi-site between Nexus data center and a campus fabric, which no one had done before. So I did this using Nexus 9Ks as the border gateways, since Catalyst does not support that today. And I don't know, word got around, and the account team from the customer reached out to me, or be like, hey, we have a customer that's trying to do this. We need your help. How are you doing it? How is it done? And then from there, it just went on. We got all their configurations. At the same time, they were also doing a shoreside data center migration. So they were going from their legacy data centers to a new VXLAN VPN data center, which we migrated as well. So there was two projects, one for the ships, one for their on-prem data centers, because the ships do connect to the on-prem data centers. This is where all the services are. So we ended up going on site to their main headquarters for, I think, 3 days. Yeah, so we did a workshop, which we gathered all the requirements, design requirements for both data center and ships, trying to figure out where the firewalls are, where the load balancers are, what is the traffic flow in both data center and ships. Lots of whiteboarding, lots of configuration review. It was pretty intense. And then for the ships, we had to go back again because they were basically setting up the ships, switches, and configuration because they're using Nexus Dashboard, doing it at one of their partners. So instead of configuring everything on the ship, they kind of had it pre-configured in a way on some of the stuff, because there are some switches that were already on the ship that they would reuse. A lot of things like Nexus Dashboard was new, so we could set it up. So we helped them with that. And I think we were there for a week for that. It was like the pre-provisioning of the ship's network.
How does it look like the data center on a ship? Is it like a rack that you can prepare offshore and then bring on the boat and you plug it and you're good to go? Is it like somewhat mobile?
They configured everything prior, like Yanni said, in a staging area, so they could then box them up, put them on the ship. So when we got to dry dock, everything was already there. The funny thing is, though, most of those configs changed on site. They actually made design changes during our cutovers, but it was helpful to at least have the right version of code and the base configs on there. But we did change quite a bit around during the cutovers to meet some on-the-fly design requirements that came up during the cutover.
We actually had a great help from a Cisco partner for the staging piece. We did go on site for staging, and we did pre-configure everything and get everything ready with software versions, with testing of all the Wi-Fi components and all that. But as Joe said, once that was packed and shipped to a kind of a dry dock area to be installed on the actual ship, design changed a little bit. So we had to go back and change some of these configurations and kind of do it during the dry dock. And the dry dock is a very stressful period of 3 weeks where the ship is in dry dock and everything must happen in those 3 weeks and everything must finish the last day, because after that the ship sails, gets customers on board, and that's it. And any delay like of a day, 2 or 3 is like a huge loss for everyone involved, Cisco and the customer. So this dry dock operation was really something interesting I have never experienced before. In my entire career, I was not under that kind of a sort of pressure to deliver at exact time. And it's not just the network, guys. When they do these dry docks, they revamp everything. So they do anything that they can on the ship, because it's opportunity to replace all the carpentry, all the electric stuff. Any retrofit that ship needs happens during those 3 weeks in dry dock, not just the network gear, which is what we did. So we had like 1,100 people on the ship working different trades, different types of work, coordinating. There were project managers coordinating everything. It was really, really kind of a well-oiled machinery, and it was executed really well.
Maybe it's a stupid question, right? But a network on a ship, isn't that just the same as a network inside a building, inside a company? What's special about it?
It is. Actually, you're right. The only, I think, difference would be of what's actually on the ship and the actual ship's data center, which Joe and Goran can tell us more about since I wasn't on the ship. Like the size of it, how many racks it has, because it's not that big. Right? Maybe it's about, I would say maybe at least the ship we did was probably about 20 switches max. But then they also have firewalls, load balancers, Wi-Fi. Because if you think about it, the ship has a lot of things on there. It's going to have things like digital displays. It's going to have things like internet. It's going to be a big thing. There's going to be things like casinos, point of sale devices that need access to their data centers, to the internet. I mean, there's a lot of stuff on a ship. It's probably more than a typical network, to be honest, because there's so many things that connect to the internet. Cameras, right? The cabins have IPTV. So there's that. There's a lot of vendors, that need to connect to their network, and we have to isolate them through the firewall. They also need internet connection. They need connection to their stuff. So I would say a ship would I would think that it has more things, services than a typical data center.
Everything runs over the same network. So it's like door locks, security cameras, navigation stuff, and customers browsing internet, pulling content. So everything needs to run over the same network, same infrastructure, segmented properly, secured properly through firewalls, through VRFs, through segmentation. That's very important. And the difference to like normal computer networks is in that the internet connection is satellite, so it can come and go. Any content that customers need and users need on the ship has to be locally stored on the ship. So all the movies, everything needs to be on some media in the ship. This is why they need a data center with racks and servers to actually store all that content and make it available to customers who want to watch movies, right? That's why they have DCs. They also have a number of internal applications for payment processing, for all sorts of things that are normally needed on the ship. So for that reason, they do need not just one DC, but normally two DCs, because now every ship has what they call like fire zones, and this is in case of some emergency, they have to split and cut off certain parts of the ship. So they normally have two data centers at two opposite parts of the ship, and some of them even are thinking to have like a third data center which they would use in the case of the DR event or some security attack or DDoS attacks and things like that. So yes, they need small DCs. Still, they need servers to store content on these ships.
So guests cannot open up their Netflix account or their Amazon Prime account. They have to use the services on the boat, right? For caching reasons as well, right? To liberate, I guess, space on the boat.
They can still, and this is like actually we had an improvement. So now they are expanding on the capacity of these satellite uplinks using recent satellite service providers who can provide more bandwidth cheaper, right? And we all know that on cruise ships, internet is expensive, but it is becoming cheaper. So now they can allow customers to actually watch online content using their Netflix accounts. But again, this is not something that is 100% warranted or reliable. Again, there may be storms, there may be events out of control of the crew that will force them to block this internet access. So basically, that's why they need to have everything available locally, or just enough available locally to offer some entertainment to everyone.
They have to pay for it too. You ever been on an airplane and they have like different types of internet you can get? Or you maybe for free you can do some messaging or browse, and then you pay extra. You can go to YouTube, Netflix, whatever. So there's that as well. And at least for the ships that we did, they used to have multiple fire zones. They had it split into 6 or 8 fire zones, like Gorham was saying. But with the new design, they ended up doing just the forward. The ship has the forward and the aft. So they ended up splitting it into 2 this time, which is a lot simpler.
What's the size of the ships that you guys worked on? Like how many passengers could they accommodate?
6,500 passengers, 18 decks, 2,800 cabins.
So give us some measurement, like how big is that ship?
I'm ashamed to say I don't know. It's very big. It's a cruise ship.
It took a long time to walk from forward to aft when you were going to troubleshoot wireless connections. I'd say it's like several football fields, maybe 3 football fields long.
The one we did was small. So yeah, it wasn't their biggest. It was just a mid-sized ship, but they have also large ships. As a matter of fact, there's a new ship coming up as well, like a brand new ship. We're going to be doing their network there as well. We're helping them because, after a few dry docks, so after 3 or 4 dry docks, we hand it over to them. Right? We can't be going to Europe and Bahamas and everywhere the dry docks are all the time, which sounds nice, at least some of the places, but at some point we hand it over as well. So now they do the dry docks themselves. We just are there for support in case they need something. But they've gotten pretty good at doing it. So we rarely engage with them today, except I still get emails and calls and stuff like that for various things. At their on-prem data center, if they have questions about the ships. So, but it's not a lot. It's nothing like we did before. I mean, we literally had to reverse engineer their whole network. We've spent weeks and weeks with going through configs, diagramming their network, figuring out their flows, because we had to give them a solution design document. We had to make sure that we knew how their network was. I mean, I'm not trying to boast here, but the customer themselves will tell you that I knew their network better than some of them. They mentioned that because of the configs and trying to then translate those, right? Because there's a legacy type data center. There's Nexus 7Ks using VPC. Then they had their catalysts that were just being routed. So we had to convert all of that to the new VX and VPN design using multi-site, take all their networks, convert them to VXLAN networks, configure VNIs, and when you have hundreds of VLANs like that, and we also had to put it in like a spreadsheet and import them. You're not going to configure them one by one in Nexus dashboard. So we had to do all of that to be successful. Goran said we were there for 2 weeks, and I think it was 3 or 4. It might have been a while, but you cannot delay the ship because the network's not working when you have thousands of customers that paid to go on a cruise. You can't delay that. There was an issue one of the days with NAT, okay, network address translation. We could not get it to work because they were natting it through the firewall, and there is a specific vendor, I'm not going to say who, that did not like natted DHCP requests. It was for DHCP.
Mm-hmm.
Okay, because of the way VXLAN handled it. I was working from the hotel, and we spent at least 15 hours through the night, if not more. Like, we spent a long time on that issue. And at the end of the day, we ended up having to change the design to make it work without NAT.
Yeah, you can't just say, yeah, it's not possible because of this other device, right? It has to work. Like, figure out a way to make it work.
Exactly. We had to figure out a way to get it to work and to get it to work right, which took us 20 hours after troubleshooting this. And we were like, okay, we got to think of another way to do this. There was some firewall design changes that we did too. Go ahead, Joe.
Yeah, something to think about on these dry docks is, like Goran mentioned, we have this hard timeline of the ship's going to sail. Everything has to be done by then. But also, when we have these cutovers during the dry dock, there's people, thousands of construction workers on the boat that need access to the internet. So, as Yanni mentioned, we had to stay up for 2 days, really, fixing this issue because all of the construction workers were ready to riot because they couldn't text their families back home. So there's a lot of high pressure timelines in this dry dock, and the amount of money they spend on these dry docks are insane.
I want to come back on something you started with. You said you're doing the migration during the dry dock operation. All the ships have to be upgraded eventually. So they all are upgraded when they are in the dry dock. So they come for maintenance, and that's when their network is upgraded, right? So it happens over a longer period. But you said also the kind of headquarter data center, the on-the-ground data center, was also upgraded kind of at the same time. Was it like simultaneous? Isn't it like putting all the risk, together at the same time? Like, it sounds dangerous to me.
Well, their data center migration was on a stage approach. It wasn't happening at the same time as the ship upgrade, because the ship upgrade happened within 2 weeks. You're not going to migrate a data center in 2 weeks. So that was more of a stage approach. I mean, it took them at least a year, if not 2, to finally migrate everything on the shore side data center. And there's still some things lingering there as well, because they have 2 data centers, right, for disaster recovery. Even this morning, I was in a 3-hour maintenance window with them to bring up multi-site for the new data center. So like I said, they're still doing things. So yeah, it wasn't in parallel, luckily, because that would have been even more stressful. You can't be doing 2 migrations, one for the ship and one for the data center, and needing to be at, especially with the time change, because we were in Spain, data centers are in the US, so you can't be trying to be available for US time and Spain time. That would have been way too draining. That already was.
And on the ship, how does the migration work? Like, in the beginning, you have time pressure for sure, but in the beginning, you're just bringing like the new network and so on, and the workers can use like the old network. But how do you like flip over from the old to new? Like, is it a quick transition? Was it painful? Did it take a long time? Like, how does that work?
It's a blackout pretty much for the gear that's been replaced. So the crews have a plan what to do when. And this hardware replacement, I don't know if you're talking about hardware replacement, I think. So to replace existing switches, the crews have to, remove what's been there and put in the new stuff. And that takes 1 to 2 days. And it happens at the very beginning. And at that time, the majority of other work didn't start yet. They actually schedule who comes to ship at what time of those crews. So they plan it. So on the customer side, the project management is really, really well kind of developed. They really know their stuff, and they know even to a low level detail, they know what problems will they have with what crew and when. Basically, that's how skilled they are. So they make this plan, and during this hardware replacement, all that's been going on, right? So not everyone is on the ship yet. The old gear has been pulled out, the new gear comes in, everything comes online, everything's kind of being tested, and at that point, like 95% of things work, and the rest of the crew can come in. But the 5% that's not still working, that's what we work on, right? To kind of iron out all the issues on the network and make everything available. Go ahead, Joe.
Yeah, in our cutover, we had phases, so everything was dual homed in the data center, like it should be. So that helped. So the first cutover we did, they powered off all of the A side gear and ran through a battery of tests, made sure everything was working just on one leg. And then over the next couple days during the day, they removed all that gear and put in all the new switches. And then we had to do the next phase was switch everything over to the new switches. So they're running on one leg on the new switches, and then would put in the redundancy as the final step. But they do really have the process down of how to do this on their ships. And there's people waiting to do work, like Ron mentioned, that the first part of the work has to be done before they come in. So it's a very timely, well-oiled machine, the way they do these cutovers and testing. It's all done during the middle of the night, but there's construction work going on around the clock. It's very noisy. It was a very weird environment to work in. You're used to being in data centers where you're just dealing with the whine of the fans. Instead, you've got saws, hammers, people yelling. It was interesting.
Don't forget, you have to wear those heavy boots and a helmet, right? As you go through those areas. And the ship is like 330 meters long, 42 meters wide, and has 18 decks and has like several elevator shafts, right? So you have to kind of walk a lot during your day, back and forth, and having all this protective gear on you doesn't make it easier.
I mean, I was in a hotel, but I wasn't allowed on the ship because of safety reasons. So I didn't have to go through all of that.
You mentioned the NAT problem. I think that was one all-nighter you had, right? Because you kind of
Yeah,
had to just work until it was fixed, but anything else?
that was the big one. So we did some design changes too, like the firewalls. They had some issues before, and we had discussions which lasted a few hours to figure out if we want to do VPC in the firewalls or not VPC. And the conclusion was to do non-VPC. So there is that design change. I don't remember if there was anything else because this was like 3 years ago. But the data center side, we've had a few bumps. And on the shore side data center side, we had a few issues, things with like the HSRP coexistence that was configured. And then they ended up shutting down one of the SVIs before it was even migrated, which you're not supposed to do because that's the whole the whole reason of the HSRP coexistence. When you shut down an SVI in the old network, the assumption is everything from there has been migrated, but they didn't actually move the firewall from the old network to the new network. There's just a misunderstanding there. So there was a small outage. There's issues with MTU and VXLAN because a lot of times of application, and this happens all the time in migrations, the application will work completely fine in their old network. Then when they migrate to VXLAN, it stops working or it's not working efficiently or there's something wrong. And that's because in VXLAN, we have an extra 50 bytes of header, which needs to be taken account. So a lot of times customers don't configure the MTU correctly and they'll have issues when they're migrated. That was another thing. And there is issues with replication for that. So now we're actually doing multi-site for replication for the shore side.
Do you have to increase the MTU of just 50 bytes, or because you're going fabric, you just say 9,000 bytes everywhere?
Yeah, usually we do jumbo frames.
Oh,
So
exactly.
to make sure.
We find out that 9100 is what works everywhere with like all gear, all vendors, all servers. So we just go with 90 our part.
Yeah, because not a lot of vendors support 9216. So like Goran said, usually 9190, 9198. I mean, even some of our own switches don't do 9216 like Catalyst, 9198.
Sorry, you mentioned HSRP coexistence. Do you mind telling us what HSRP is, what's coexistence, and why is it required in this case?
So HSRP, Hot Standby Routing Protocol, is a way to have your default gateway to have high availability. And so you have an active device and a standby device. It's there. You have an active switch, you have a standby switch. So in our old networks, we didn't use distributed unicast gateway where the IP address And the MAC address is the same across all the switches. In the old data centers, we use things like HSRP or VRP, which is the standard version of this HA gateway. So they had HSRP in their network, which was good. And the reason we would do the coexistence when we migrate from old network to new network, being the X and the VPN, is to make the migration of the default gateway as seamless as you can. Because if you think about it, when a host moves from an HSRP gateway to an Anycast gateway, there are two different types of gateways, right? One uses HSRP, one is just a static MAC and static IP. So to make that migration more seamless, we have a few options. One is to shut down the SVI and bring it up on the other side, which a lot of customers do, especially with VRP, because we don't have VRP coexistence. But the other option is really to use the coexistence. So what that does, it's a new feature, is allow you to have run both HSRP and distributed Anycast gateway. Because without the coexistence, it doesn't work. So with the coexistence, we did it so they can migrate their default gateways seamlessly from their old Nexus 7K network to the VXM network, but ended up biting us because of the misunderstanding there, right? The whole reason of this is to make the gateway seamless, but you need to make sure that everything from the old network to the network is migrated, and then you shut down the SVI, if that makes sense. I talk about it in my Cisco Live migration session too.
We had an interesting technical issue with multimedia. So you know how they have like a stage for performers on the ship where they play music, and there's lights and everything. Well, all those lights actually use multicast streams and special network configurations to support them. And what they use is a PTP or point-to-point time protocol on the wire to synchronize everything. So when we moved from the legacy configurations to VXLAN and we also replaced gear, the way that multicast works in VXLAN is a little bit different to what it's in the legacy configurations. So what happened is that it just didn't work, right? The lights didn't work. And the reason is that all those PTP clocks were kind of seeing each other and kind of started to being mixed. And this is because we kind of routed all the multicast by default because we were not very clear with the requirements for those applications initially. When we realized like what's going on, we were able to kind of tune the configurations and overcome the issue by not routing multicast for those VRFs that involve those media servers. But it was very interesting, and it was like a big crisis from the customer end. Like, I don't have my light show. What's going to happen? Like, I must have it.
It was a literal showstopper.
Yeah. It was a big showstopper.
You guys were using TRM for PTP?
Yes, we were. We didn't know that they use PTP in that capacity in which they were using it. So we configured TRM for different reasons. They have IPTV, they have music, they have all sorts of things that customers pull using multicast. And talking about that, it's very interesting how they have this design. So everything, including multicast, flows through firewall, and it's a non-Cisco firewall. It's a third-party vendor, and we had to be very creative how we provide these configurations, because this was a change in design also in this upgrade compared to the previous design. So customer wanted to direct everything through firewall going forward, and we had to run TRM from one VRF to another VRF through an external firewall. So in one VRF, we would use like an internal rendezvous point for multicast, and for the other VRF, we would use that as external rendezvous point, which was very interesting configuration. And I had not had that use case since then. It was a unique use case to me.
And that's the whole point of architecturing, right? Because you don't need multicast in every part of the network, right? It's required for some services, but you don't want to allow any kind of multicast anywhere. And then it causes a lot of questions, right? Especially in the fabric. Like, you have to think about how to configure it.
Yes, it is required, and it has to be carefully configured to provide exactly what it needs to provide. Because if you have a TV channel and 1,000 people want to watch that TV channel, then you are going to use multicast for that to distribute it to at the same time to 1,000 endpoints. So that's why you need it. But then again, you have to be careful. Many applications use local subnet multicast, what's called, right? So like things like Apple TV, things like that use MDNS and things like that, they use actually local multicast within the subnet. And when we do these configurations for the VXLAN, we kind of have to support routed multicast, but then we have to be aware if there is any multicast that does not want to be routed, right? And that's kind of a what's important there.
Yeah, if someone plugs an Apple TV in a room, you don't want that to be rebroadcasted everywhere on the ship, right? Like that kind of stuff has to be avoided, and you need to know where is advertised what, right?
Absolutely. Yeah, you got it.
And you don't want the IPTV stream to be on the boat operation network with the engine and stuff as well, right? Everything has its place and should stay there.
Yeah. So those operational like engine stuff and security stuff, they have their own separate segmentation domains, and they are not going to be mixed with anything else ever. So that's secure for the, as you said, like we don't want kind of a customers on the ship to kind of interfere with each other, sniff each other's passwords and things like that, right? We don't want them to do that.
Can we discuss about why a fabric on a ship? Because fabric is a no-brainer in a company data center, for example. But why the fabric on a ship? Typically, the arguments are here for fabric are the segmentation, because you're going to use secure group tags to tag traffic in a more easy manner. A segmentation in terms of VRF, etc., which is better than using VLANs and kind of homemade ACLs. What are there any other reasons that I'm missing? What's the driver there?
I can speak for the customer that we did. So they had a legacy data center, right, running spanning tree on their data center, which a lot of times they actually had problems with loops. So obviously that's like the number one thing. We want to get rid of spanning tree because not only were they having loop issues with loops or broadcast storms, but it's not efficient, right? Some of their links were shut down, some of them, and they weren't being fully utilized. Sure, you could do odd and even VLANs, as I talked about HSRP, where one's active for the other, but you're still not going to get efficient load sharing between those because you don't know what the traffic's like, right? Everything maybe in database will go to switch 1, and everything that's not database might go to switch 2, which database traffic might be a lot, right? So you're not getting efficient bandwidth. So the idea was to eliminate spanning tree, being able to have host mobility, and being able to move VMs from one switch to the other. So by which VXLAN with EVPN allows, having an actual control plane instead of dealing with flood and learn like we do in classic networks. So active learning. And then on the campus side, they were doing multiple VRFs, right? If you have 10 VRFs, they were actually doing a bunch of VRF lights between their access switches and their AG switches. They didn't have like a regular classic network in their campus. They had a routed access network. There's things that you could do like run MPLS, which they weren't doing. But since we were already going to go with VX and EVPN in the data center, we decided to do the same thing in the campus and be able to get an end-to-end overlay and being able to scale each network in their own segment, right? Also being its own failure domain. And they also need to be able to extend VLANs from their campus all the way to their data center because they have vendors that would connect the campus switches to some other switch somewhere in the ship, which goes to the campus, right? You don't connect things to the data center. That's all their services. So the vendor's default gateway was the firewall. So we had to extend layer 2 all the way from the campus to the data center service leads for them to be able to access whatever in the ship, which we were able to accomplish using VXLAN with EVPN, having that overlay and multiple other things, right, there that VXLAN provides with EVPN.
Yeah, our customer had like 10 VRFs, and there were flight links everywhere in the legacy configuration. So moving to VXLAN overlay, it's like you're putting your virtual overlay over like kind of an underlay network. And every time you add a new VRF or new security domain, you're only touching certain pieces of gear. You're not touching every single link in the fabric, which is what makes it more flexible. And which is what traditionally this was used with MPLS domains from the service provider side to provide service to many, many, many customers. And in the campus networks today, we have this increased ask for security to have more security domains in the campus. So not just Corp and Guest as we had before, but now we have many, many vendors. We have many different asks on the campus side, and the overlay technology like VXLAN makes it much more clear to actually implement those configurations and add or remove those overlays. It's much more flexible and it's easier for operational teams to support.
It sounds like you said, so Cisco helps with the first deployments, but then tell the customer like, now you have the blueprint, feel free to roll it out. I suspect the customer might be able to tweak some things more easily because they have the blueprint of a ship. The next ship might be slightly different. Maybe instead of, I don't know, one casino, they have 2 casinos or whatever. but because they know everything is in its own virtual network, everything is segmented, they can just add, let's add a switch there, let's add, and it's still kind of the same architecture, right? And it's going to work because it's all layer
Exactly.
3, it's all architecture is well designed. It's not like if it's all layer 2, then you add too many. It's like, oh, now you have, broadcast domain is insane, or now you have this problem. It's a more flexible architecture, right? Because it's thought from the
It's very
get-go to
flexible. I'll
be.
give you an example on that. So when we first deployed this specific ship, the first one we did is actually going to dry dock this year. I think it already dry docked. So the initial design was to be our typical Nexus data center, Nexus 9K, which fine, right? Nothing changes in the data center, but their campus design, instead of having multiple leaf switches, they had just a pair of switches. I mean, it was 2 campus leafs, but they were doing VSS. Okay, so it was a stack basically of, I think, Catalyst 9500s or 9400. Now, this new dry dock, they actually changed their campus design. So instead of having just 2 leaf switches, now they're going to have about 13 or 14 switches. They are going to be stacked, but they're not going to be 9500s, which I think they were their chassis. So what you said is perfect example of what they really just did, because it's so flexible. Just add more leaves, which gives them more ports, and they were able to scale their data center a lot more now, because instead of having 2 switches, they now have like 12 or whatever they did for the leaves. And they were able to migrate very easy too, because the Nexus dashboard, they had to put that new fabric in Nexus dashboard, they had to connect it to multi-site, and then now they were able to move things from the old campus to the new campus. So it was pretty cool.
And how many ships did you do exactly? Because I'm not sure if you said you did only one ship or you did more than one. You said you didn't want to do all the ships of the customers.
We did, I think, 3 total dry docks. I only was physically on one dry dock because they won't allow me in the ship. Joe and Venkat, I don't remember. I think Damon also went to a few others as well.
I think there was 4 total ships because I did 2 dry docks, one solo, one with others. I think the first one we were all together, but it really helped the customer because they sent their teams and learned on the fly during the dry docks, as well as learned during the staging. We gave them run books, support, and kind of taught them how to do this on their own, which they do now. One challenge they had, though, was all of those engineers that came to the dry dock and learned VXLAN and Nexus Dashboard, they're shoreside. They don't ride around on these ships. So once these ships are out at sea, they have a few operations guys on there that basically do move, add, change type stuff at the port level. They make CLI configs at the port level, and that's kind of their extent. So there was a lot of angst of once this ship sets sail, what if we run into issues? These guys on site, they don't know Nexus Dashboard. And so there was a lot of worry up front, but I think the model they have works pretty well. They support pretty well remotely now.
They did want one of us to ship actually with the ship. As a matter of fact, on the new ship, one of us might be going on there since it's brand new, and they want to make sure nothing happens.
Yeah, so they told us actually that replacing a switch on a ship which is sailing somewhere using a helicopter to deliver the switch is like a $2 million operation. So they don't want that anything like that to happen, obviously. So yeah. No pressure.
So we had already a previous episode with troubleshooting on a cruise ship. And the problem is that you need to know where the cruise ship is going to stop to go on board of the cruise ship to troubleshoot as, the ship is traveling. So I guess if you have to ship a device to a ship, the problem is to know when the device will arrive in which port, to know the boat will be there at the same time. And maybe helicopter is the easiest there, or it depends, right? It might be complicated.
So I did not know this, but for example, if the IP phone in the cabin is not working, they have to replace the cabin for their passenger. Basically, they have to move them to a cabin where the iPhone works. And if they can't, they have to station someone like a guard in front of those doors to be there 24 hours. So if customer needs help and yells at something, they can react to that.
Just in case they're locked in or whatever like that.
Yeah,
right?
yeah. That's like a regulation, strict regulation they have to follow. I did not know that, but yeah. Next time I don't like my cabin, I might say like my phone is not working. Right? So
you fiddle with the cable and you're good to go.
Yeah, as a network person, you would know how. So you're either going to get moved or you're going to have your own private guard at your cabin.
So to come back on the value of CX services, I mean, I guess it already makes sense. The value is to get the blueprint, right? It's not just do this network for us. It's like we want all these technologies, but where do we even start? Because it's definitely a complicated project. So you get Cisco's help to develop the best blueprint that you can then live with and adapt and so on and so on. But you also faced issues during the deployment, right? Because there's interrupt with third party, there's always problems you cannot foresee, and you could escalate immediately, right? So you knew you had 3 weeks when the ship was dry docked and stuff just happens, right? So you had problems resolved very quickly as well during the...
Yeah, the first few dry docks, you find out what are the potential issues that could happen, like the mat thing, because they were doing it on other ships too. So we knew that, okay, this ship, the first one we did, you're going to have a NAT issue. So this is how we're going to design around it. This is how you do it for the rest of the ships. Or this is how you're going to design your firewalls, since, that's what we agreed on. Now their ships, instead of having 2 switches, right, they're going to move to multiple switches as at the leaf layer in the campus. So you're 100% correct. I mean, our value here is literally being the experts at deploying and migrating our equipment, right? Using our Nexus dashboard, fabric controller. I mean, I know Goran for sure has a lot of knowledge, right? A lot of experience when it comes to VX and VPN, both for campus and data center. Joe and myself as well. I mean, I'm doing this stuff pretty much day in and out in the lab or for other customers, labbing things up. So we are the experts for this, and that's really where our value is. And being able to reverse engineer somebody's network to learn what it's supposed to do or how it works, to be able to translate that to the new design and documenting everything, making sure that their migration or their project goes as smooth as possible. Because when you have strict timelines like 2-3 weeks, there's no messing around. You better know what you're doing.
Exactly. Like if in the middle, like we're not going to make it because we have this, hard to foresee bug or whatever, you can't really roll back, can you? I mean, it's the next dry dock is not going to be before a very long time.
No, there is no rollback. So if you see an issue that's like that you think is going to last for more than 1 day to resolve, Cisco pays special attention and engages all possible resources to resolve the issue. And this is where Cisco account teams and everyone else stepped in big time to immediately ship and help us resolve that.
That's another advantage of having CX directly busy with the design and the deployment and the testing at the same time.
Yep.
That actually reminds me, for our first ship, I think it was optics and brackets, whatever they use for mounting the switches. I think maybe it was for Nexus dashboard. I'd forgotten that, and they ended up shipping it to my hotel like overnight almost. I know they paid a lot of money, and I had to sign off on it and everything. And then they were sending me emails to pay customs on it too, because I was a recipient.
Just take a helicopter and bring it on the ship. I mean,
Yeah. I do want to give props to the business units for like Nexus Dashboard and Nexus itself, like the OS, where they were almost on standby the whole time because this was going to be their first deployment of VXN multi-site between campus and data center. If we had any issues with anything, we were messaging them. And luckily, a lot of them were West Coast, so the time difference kind of worked out as well, especially in the middle of the night or early in the morning. They were almost instantly available.
That first dry dock, remember, Yanni, was not generally available code. We were using an engineering release code. So yeah, there was a lot of worry with it. They also tried to do virtual Nexus dashboards, running them as VMs on an unsupported hypervisor. So it wasn't VMware, and there were issues with that. So they eventually switched over to physical Nexus dashboards instead of virtual. But that was all account team and BE support being really on the ball, like Yanni mentioned.
like another factor, right? Have you done this before? No, but we think we can make it, and we're going to get the right people
Yeah,
on it, and it will happen. Okay.
We tried to get it to work when we were staging, and there was all kinds of issues, and even the hardware was some other vendor, and it had issues with like when reboot, it wasn't keeping something in memory or in the battery or something like that. So every time you rebooted, the ND would not come up. So there was a lot of issues between the hardware and the hypervisor that we were just like, here, use PND and call it a day. And today they're still using physical NDs because I mean it's the best way to go. It's our hardware. It's proven to work.
I think we've covered a bit all the aspects of the project. Is there a big learning, a key takeaway you have from it, from ship migration like this?
I would say the biggest thing is the stressfulness of the short timelines. There's no, like we mentioned, there's no delays. Like you can't delay this because the ship has to sail. They're going to lose millions if it doesn't sail, and reputation. You're like, oh, this ship was late for sailing. Like, what's the reputation of the customer going to look like? And ourselves, right? Cisco reputation. We're supposed to be the experts. We know what we're doing. So making all these last minute design changes, workarounds, and things that are going to make sure that it's going to be stable, because, they don't want to pay $2 million to bring a helicopter for a switch or for something else there. I would say that would be my biggest, and the fact that I can't go on ships because of safety reasons.
Yeah, mine is like preparation. I think that's the key. Staging and good preparation is really, really important here, and trying to minimize any changes during dry dock. Every change is going to be risky and not tested, so I try to avoid that. The other thing is like get a good night's sleep maybe a week before this dry dock, because initially I think everyone sleeps like 3-4 hours a day or a night during night, right? That's how long the days are. The days are really like 18 hours plus when you're in the dry dock, because there's so much things to do and there's so much things to even to coordinate. As Yanni mentioned, there are different time zones, right? So if you need help from someone who's like in India or in US and you're working in Europe on the ship in like Rotterdam, then it's kind of no one cares who's in which time zone, right? So those meetings run like for hours and everybody's trying really hard to resolve any issues that we have. So yeah, we have good preparation and be ready for hard work. That's my take up.
Yeah, I'd 100% agree with Ron. Getting that staging done and tested as much as possible really help deal with the short window that you actually have to get the work done and respond to all of the issues that you know you're going to run into. And then trying to get sleep while there's 24/7 construction work going on. It's a rough environment. Having as much done and tested prior to going there was key.
Thank you very much, Goran, Joe, and Yanni. It was really great to have you today. We learned a lot. Thank you again. Have a great day.
You're welcome.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us by searching for the channel called Cisco Tech Stories on your favorite podcasting app. We're also present on the Cisco Podcast Network channel, where you can discover other podcasts from Cisco. Feel free to leave us comments or questions on Spotify. Thanks, and see you next month.
The horizon glows, a line of blue and gold. 1,000 stories waiting to be told. Below the deck, the heartbeat starts to hum. The data center wakes, the packets start to run. From the bridge to the stateroom, the signal flows. A digital pulse where the ocean breeze blows. Oh, we're sailing on a sea of connectivity, where the network holds the heart of the mystery. From the Wi-Fi dreams to the data stream so wide. 1,000 miles.